radio wave propagation or electromagnetic wave propagation. The electromagnetic radiated wave travels through different paths to reach at the receiver antenna. The path taken by the waves to travel from the transmitter and to reach at the receiver antenna is known as wave propagation. The propagation of electromagnetic waves may be divided into following categories. First one is ground wave or surface wave propagation. Second one is sky wave propagation. Third one is line of sight propagation. Includes space wave or direct wave propagation. Let us start one by one. First is ground wave or surface wave propagation. A ground or surface wave travels along the surface of the earth. These waves are vertically polarized, so vertical antennas are useful for these radio waves. If a horizontally polarized wave are propagated as a ground wave, due to conductivity of the earth, the electric field component of the electromagnetic waves get short-circuited and will not travel for a significant distance from the transmitter. Due to curvature of the earth, vertically polarized radio waves become parallel after traveling some distance and get attenuated. Instead of just traveling in a straight line, the radio signal tends to follow the curvature of the earth. This is because currents are induced in the surface of the earth and causing wave front of the radio waves to tilt down towards the earth, and due to this tilted wave front, ground waves is able to curve around the earth and can be received beyond the horizon. Since ground losses increases rapidly with the frequency, hence this propagation is used practically in the low frequency and medium frequency portion of the radio spectrum, that is up to 3 MHz only. The maximum range or coverage of the ground wave propagation not only depends upon the frequency but also depends on the power of the transmitter. Second one is sky wave propagation. To understand sky wave propagation, first we have to get idea about ionosphere. The ionized region in the upper part of the atmosphere of the earth is called ionosphere. Ionosphere starts from 48 kilometers to 965 kilometers from the earth's surface. There are three significant layers for the sky wave propagation of the ionosphere, that is D layer, E layer and F layer. D layer is from 60 kilometers to 90 kilometers. E layer is from 90 kilometers to 150 kilometers and F layer is from 150 kilometers to more than 500 kilometers. During night time, only E and F layers exist, whereas during daytime D, E and F layers exist, and F layer is also divided into F1 and F2 layers. Now we have understood ionosphere, so we will discuss about the sky wave propagation. In the sky wave propagation, the upward transmitted electromagnetic waves reflect from the ionosphere and return back to the earth's surface. Most of the long radio communication of medium frequency as well as of high frequencies are using sky wave propagation. Even short waves are also transmitted using sky wave propagation. Now we will discuss critical frequency. Critical frequency for an ionospheric layer determines the highest frequency that will be returned down to the earth by that layer when that transmitter is transmitting straight upward in the sky. The maximum frequency that gets reflected back and reaches to the receiver antenna at the earth's surface is called critical frequency. The frequency range which is preferred for the sky wave propagation is from 3 MHz to 30 MHz. Now we will discuss space wave propagation. Space wave propagation takes place when the radio waves from a transmitter propagate through space around the earth and reaches at the receiver end. The radio waves can propagate either directly or after reflection from the ground or reflection from the troposphere. This type of radio waves propagates within 20 kilometers from the earth's surface. Space wave propagation comprises of two waves. One is direct wave and another is indirect or reflected waves. Follow line of sight propagation, whereas indirect waves have two components. One is reflected from the ground and second one is reflected from the troposphere. Frequency range which is preferred is from 30 MHz to 300 MHz. Since one component of space wave propagation is direct wave which follow the line of sight propagation, So we will discuss the line of sight propagation. In the line of sight propagation, as the name implies, the wave travels a minimum distance of sight, which means it travels in a straight line from transmitter to the receiver. In LOS propagation, means line of sight propagation, waves travel in a direct path from the source to the receiver. The line of sight propagation will not be smooth if there occurs any obstacle in transmission path. The reflection and diffraction of the signals above 30 MHz does not affect significantly. Thus, any obstruction between the receiver antenna and transmitter antenna will block the signal. Therefore, the ability to see the transmitting antenna roughly corresponds to ability to receive a radio signal. The farthest possible point of propagation is called radio horizon. The two stations which are not in the line of sight may also be able to communicate through an intermediate radio repeater station. The main applications of the space wave propagations are line of sight communication, TV broadcast, microwave links, radar communication, satellite communication like DTH services, etc. This was all about wave propagation. Thank you for watching HTV. Simply watch and learn. Jai Hind, Vande Mataram.